Steady. So the best way to learn hardware and how to fix things, similar to software, is learn by doing. I basically just learn by going at something. So what I've got here is a broken Game Boy Color. I've no idea how they work. I know basics of electronics, all self-taught, but I have no specific idea of how anything works. It's come in the post. It's literally broke. I haven't touched it. I haven't done anything to it yet. And I want to do a video on me attempting to repair this. So I don't know whether I will or not, but this is a perfect way of how you learn hardware, the way I learn it. So let's get to it. So the first thing we'll do here is, it's arrived saying it doesn't work. So let's obviously test it doesn't work. I haven't even tested that. I'm saying it doesn't work, but just put some batteries in and turn on. We're getting absolutely nothing, so there's no power light. These batteries are actually getting really warm, so that's something to start looking at. If those batteries are getting really warm, then we've probably got a dead short between the pins, and it also looks like, looking at it now, I'm guessing that's water damage, which probably means this is fairly damaged inside, but let's just start with seeing if these are dead shorted, then we'll take it open. So if I just grab a multimeter, and to test what's called continuity, whether things are joined, just look for typically like the buzzer sign, and then you touch them together, you'll get a beep, and they're not joined, so the batteries are getting really warm, but it's not through simply a dead short. Let's just try resistance and see what we get. No, so that's not necessarily the issue. It's not as simple as that, but it has, by the looks of it, had some water damage. So let's just start by really opening this up. I can also see on these screws as well that they've got crap on, is the only word to describe it, which is a clear indication of water damage. This has got all this powdery white stuff, which is usually a sign. So I'm pretty sure this has been completely submerged in water. So that'll be interesting. Right, so you can see straight away here, we've got, again, this green is, and all this lovely, yeah, don't know what that is. But we've got a lot of damage in here, water damage style. You know, there's all kinds of stuff that does not look right. So the first step here really is all this green wants to go. So I'll remove a bit more of this first, see if we can get to the bottom. This will be the cable for the screen. So you just pull the two tabs there. So that's that out of the way. Has this been held in by any screws? So we've got two screws here, which are posi screws. And by the way, I wouldn't buy one of these wow sticks, quite frankly. They're useless. You can hear how it's struggling to barely unscrew a very loose screw, so I would not recommend these. I mean, you can even see under the buttons all the, yeah, I'm pretty sure toilet water, to be honest. That's making a right mess of the desk. As always, like I say, the things you do first is the obvious. This is covered in green gunk, nasty crap that shouldn't be on there. So the best thing you can do is start by just simply cleaning this. So again, get IPA fluid. We've got that much, to be honest. I'm just going to squirt it all over the board. Just cover this thing with IPA. This is perfectly fine as long as there's no power on the circuit. Get rid of all the crap that you can. The only thing we probably shouldn't do is put it in a speaker, but to be honest, I could swap this speaker out if we got it working. I'm not too fussed about that. And if you're going to do this, do make sure you're using IPA fluid. Don't just, squirt any old fluid on there. Obviously, all this gunk is not going to be doing anything good for the circuit. It will be obviously causing resistances to change and things to short together. So you really want to attempt to get all this crap off. And don't be too afraid to be fairly aggressive. You don't want to go, you know, really hard because it is electronics, but at the same time, you know, you do need a decent amount of force to clean this off. I'll do this side as well now. And you can actually see on here, over these pads, it doesn't even want to come off. It's almost like we want to scrape this off. It's that sort of, that's really corroded. Right, really, really corroded on. So this has obviously had some water damage for a while and been left and just really soaked in. We might need to like repair the pads. Luckily, I used to modify Xbox consoles and controllers, and these are simply two pads that join together when you press it with a rubber. So these pads are conductive, and when they press, they just join these two together. And because this is a start and select button, I know these pads just basically need to join together. So if they come off, we can fix that fairly easily. But yeah, this is really heavily caked. At the same time, these things aren't really going to stop it powering up because these are just buttons. But go between the pins that clearly shouldn't be joined here and sort of scrape between. And we're just trying to get any signs of sort of, you know, rubbish or gunk off the board as best we can. So looking at that now, I think it's could obviously be improved, but this area didn't look too good. That had a lot of the damage. I don't think, unless a few of these, if anything, I would say maybe these resistors or capacitors were joining in this little gap here that might have been causing an issue. This side, the main control, if you will, and the power switch here, unless the power switch was faulty and it wasn't applying power, that could be one issue, so these pins weren't joining, but clearly that wasn't the case because these batteries were getting warm. So we do have some issue down here, but we might also have like a dodgy power button. So if the clean hasn't worked, then all we're going to do after that is dig into basically the voltages and see where it goes and how much power it draws and figure that out. So I'll go into there. And also actually looking at the screen cable itself has got a lot of gunk on the edge here. And you do want to be careful with the screen. You don't really want to get any IPA fluid into the screen because obviously it can affect the actual screen itself. You'll end up with like liquid in your screen. So keep the cable away from the screen. So that could well have been causing an issue. That is definitely a possibility because the screen does draw quite a bit of power. So if those pins were shorting together, that could cause any kind of issue. You can see this is even just fell off, just moving around. So that's just ripped off. We'll fix that and probably swap the speaker out. So let's plonk this in here. Put that over here. There we go, so that's back on. And then we'll need tweezers to try and turn it on because the button's out. And still nothing. So see if the batteries get warm this time. No, the batteries aren't really getting that warm. But let's just start by checking what voltage is on the battery. So we've got 3.2, which is fine. So really to go past this now, we need a power supply so that we can have this open and powering up at the same time. So we can apply power to these pins and then probe points on the circuit board to try and see what's going on. The best thing to do now is we have a power supply. All this does is provide power to the circuit. So I can manually basically clip on here and clip on here to apply some power. So I'll turn on the power supply here and you can see we've got no power being drawn. So I'll just wiggle the power switch. Nothing changing here. So just to test the power supply, I'll just get these clips and tap them together. And because I've got current limiting on this, you'll see that when I tap them together, it's dead shorting and providing 1.5 amps. So the fact that we're getting nothing at all when we apply power to the circuit here kind of indicates that nothing is being drawn. That, you know, it's not asking for any power. So with this power applied, we could start tracing the voltage on the board to try and find where this power fails or where it starts. And if I now test between these, we should have the expected 3 volts, which we do. And then you can keep it, usually what you do is you just keep one on ground, so keep your black on ground, and you could start probing around. And like the power switch for 1, it's got 3 volts at the top, got 1.6 in the middle, and 2.5 there. So the voltages are all over the place, but the power's getting up to this switch at least. You'd expect that ground to just be continuity with this, connected. Usually shields are directly connected to ground, but maybe that's not the case here. The next suspect I'd say here is potentially just this switch. On this switch, we don't really need power applied to test this, but I don't know how this switch is working. We've got it on continuity, so it beeps when it's joined. Well, the way a switch would typically work is something would join to something else. So between these pins, you'd expect something to join them. And C will usually stand for common, which means the pin that's shared between others. So you'd expect something to join with common. When we slide the switch, oh, you can... Yeah, so it does look like the switch is faulty in some way. But the quickest way to solve this problem will be to try and get a working console. So I've already got one. So let's just take these off here for the minute. We know we have a faulty switch in some way, but let's just bring in a Game Boy Color I already have. So it's beneficial because I've got a working unit. Same with software. There's nothing more beneficial than having something that already works to compare against. So just to double check, this does work. Yeah, we get power and that comes on. So this is a working unit. So now we have something that we know works and we know is the expected behavior. So if I just take this one apart, so now we have, this is the working one. Let's see what a working switch should do. So in the off position, let's first see what there is. So in the off position, 1 and C are connected. C and 2 and C and 3 are not, and nothing else is connected. So basically in the off position, these two are connected. In the on position, I'm guessing both of these are connected. Nope. So C and 3 are connected. C and 1 isn't. Let's try common and 2 and start sliding it. Yeah, so it looks like 2 is potentially not even connected on this board. So we might be able to see on the circuit. Let's grab the old one. If we look at, we know the switch is around here, and it's labelled up. So VCC is usually power. So SW1 will be switch 1 power. VCC will be the battery power, and then switch R1 might refer to a resistance. So that middle pin might be resistance or might be the off pin. So if we held the pin on, say, C, and we held one of the test leads on C and turned over, so we can see that's VCC. So common is basically power. 3, yes, that's switched power. So it's basically applying power there. And 1, which maybe stands for reset or a resistance, I don't know, but that's the off pin. And there's no other pins on there. So that pin 2, I'm pretty sure, is not being used for anything. And when we turn it to on, the C and the 3 should connect. So a quick way of kind of I guess proving if that's our only issue is to just solve these two together. So it's already got the switch in the on position. So I can find the old speaker wire. Make use of this for the minute. And to be honest, this might fix the switch, just having fresh solder. We've got a feeling the switch is just generally broken inside. A fresh solder on all 3 pins. And because this is old, dirty wire, this is kind of not wanting to stick. I mean, it's on, but good enough for this test. But obviously, if you were doing this is in no way a proper repair. This is simply a quick way to test if just joining the 2 wires together is going to fix it. And if it is, we'll do a more permanent fix. So now, let's just apply power again. And all you want to look for this time is when I touch the power on to the power supply, do we get any power? And when we apply power this time, there's still absolutely nothing. So we're going to have to dig deeper here and start probing for where the power is. So let's do one other thing first. If we apply power, let's see what's happening on the switch, because we know the switch is kind of faulty. So I'm going to just touch on the ground here. Usually the ground of the board is the ground everywhere there's like a shield like this. And we're not getting any beep, we're not getting any ground. typically, things on a board, like say that are shields, they're usually connected to ground. And none of this is kind of beeping, if you will. There's no connection there. If I put this onto voltage, this pin, that's also, the thing that's really standing out here is that's a shield and it's got 2.5 volts on. And that is the same. But that just doesn't add up to me. That being, for one, a shield having voltage on seems very odd in the first place. 3 volts. Pin 2, it's got none, which is another suggestion it's just totally unused. And that one's got 3 volts because we joined it. But this is concerning me, this 2.5 thing here. Typically, and it's not always the case, there's power planes and other things. But typically where you see most of your solid green copper is usually ground planes. Other ones are power. But where you see the biggest one is generally the key. The one that flows everywhere is usually ground. And certainly when you see cages and things, they're ground. So I would have said this plane here is ground. We're getting voltage on it. So let's just do that same test now on the working one. And this is where the benefit of having a working board really comes in. So is that, yeah, so you see that is ground. It is connected. And this, I'm sure, is ground. Yeah, so these are basically directly connected to the battery's ground. And yet on the faulty one, we're getting voltage on. And yet there's not a dead short between them either. There should be, effectively. That means there's a dead short, they're directly connected. So not only are we not getting it connected, we're getting a random level of voltage on the ground plane, which is really going to mess things up. So what we want to do is kind of probe this working board. If we have a look at the power draw, you can see we've got 39 milliamps there. So it's trying to do something. I've also unplugged the screen just to make sure, keep things simple. And we've got the ground, we've got the power in there at 3 volts. And then it's going to make its way up through these pins into the main circuit board. This lot's all just, by the looks of it, audio, speakers, not really that important. This is where all the good stuff's happening. It's whether this 3 volts is going straight into this board. So if I just get that into there and I just probe some points, just out of curiosity, so we've got 0, we've actually got 13 volts there on a working board, and minus 14 and 5. So let's just do that quick test on them on the faulty one. I've got no idea what these do. I'm not even bothering to look up what things do. I'm doing a basic check, and you can see there already the ground is already not ground. So we've already got 2.5 volts. We're definitely getting voltage onto the ground here. That's 2.5 volt offset, but let's probe the others anyway. That's 2.5, that's 2.5. So it could well be that down here, if we just remove the power a minute, the fact that this we know should have 14 volts and things, and it still looks a bit dicey and a bit dodgy, it could be part of this circuit causing the issue. So we could clean up this more, because if you can see, it's still quite corrosive, quite messy. We can look around the board for obvious signs. I mean, there's that much damage on this board. It's not really looking for an obvious sign. It's just everywhere in the first place. But we want to try and get rid of this voltage that's happening on the ground plane. That is a definite issue that we know of now. And unfortunately, one of the hardest things to diagnose is voltage on a ground. When you have any issues on your ground, because ground is usually everywhere, that's usually a really hard thing to find. So I'm just going to probe around this board, clean up more points, and look around and see if we can spot anything obvious. Now, F1, I'm guessing that's a fuse. F1. That's not connected. I'm guessing, just based on all these numbers you see, like R stands for resistor, VR is variable resistor, C is capacitor, F is usually fuse, and you rarely see them. So I'm guessing that's a fuse, but there's no continuity. Let me just compare that to the working board. Yeah, so that's getting continuity. So it might be just a blown fuse. Now, I don't have a spare fuse, and I don't know what that fuse is. I don't know what rating it is. So something I probably shouldn't recommend to you is effectively we just dead short this, because the fuse is blown for a reason. There's been too much power draw. But a nice little trick I like to do is sort of just temporarily hold your tweezers over and current limit your power supply to basically check if anything happens and if it's normal. So I will apply power to the power pins. All I'm going to do now is touch over there with my tweezers, and if we just take a look at the power supply, let's see if when I touch this and the switch is still shorted, if this gives us any power. We're getting nothing at all over there again. So I'm just going to blob fresh solder one side, fresh solder the other, and off it comes. We can clean this up and bridge between, but to be honest, it's just a nice bridge between will be fine. I'm being a bit lazy, you probably should, with how big that gap is, put an actual wire in, but again, we're debugging, so I don't want to be too clean right now. So now we have effectively a fuse that will never blow. So we now know we have a faulty fuse, a faulty switch, but I want to get this thing up and running. Let's go back to now applying the power and double check when we apply the power on the power supply. Let's see if we get anything now. So we still get nothing. So let's carry on probing. So if I probe the ground again, and then we were getting 2.5 on this, so we're still getting this 2.5. Now, from the battery to effectively the whole circuit's ground, we're getting voltage, and yet there is no join between them. But if we go between effectively the ground of everything else, the rest of the board that you'd expect to be ground, we are getting continuity. So it's almost like it's between this point, and as we saw, this is where most of the damage was. So what I want to try and do is trace down where this goes to end up here on this area. I've got a feeling it's got to do with this area. This is where all the damage seems to be. So we don't need power applied for that, because we're basically following and tracking down a circuit now. So what I want to do is follow where this pin goes and what happens to it. So if we look, this is the battery negative. You can see this faint line here. So this is where the battery negative's coming in, and it's going along and comes down to here, and then it gets difficult to see, so you just have to try and get the right angle and trace exactly where it's going, but you can see it's coming down this line. And what we're best doing really is probing the working Game Boy to figure out where it should go and then compare to where it doesn't. So I'm just pointing on the battery input, and I'm going to track on the working board. Let's get some reference points that we know. So this should be ground, and you can see it says P5 ground as well. So we've got ground on that pin, ground on the pin up there. So these two are ground pins, and ground. So 2 grounds there. So let's look at those on the broken one. Let's just see. So this should be ground, and it's not. So we've already lost ground somehow. Same there. Same there. So, but this one's trying, and then we've lost it here. So that's interesting. We have ground here, and now we've lost it here as part of this, whatever this is here, which I don't even know from the Game Boy, to be honest myself. Maybe it's a small power input. Does the case tell us what that is? Yeah, that's the DC 3 volt input. So interestingly, the DC 3 volt has only got ground on one pin and then not on the other. So let's just compare that to the working board. So we're looking like it might be something related to this DC input here. So obviously that's connected, should be connected. There's no real reason. So that'll be the 3 volt, that'll be the ground. So now let's just apply power. And I know we're not applying power to the DC input, but what I'm trying to see is, do we have voltage on this input? To see if it's simply a shared line that you can simply apply it from the batteries and it'll go straight to the battery circuit, or whether it's an independent circuit that will work differently. So to do that, now we've applied power there, and we're on voltage. See if we get voltage on here. So no, we're getting no voltage on this input here. So it's not passing it back through, it's going to go through some circuitry to end up generating the voltage. So that's just, again, I've no idea what it's doing. I'm not trying to figure that out, and that's sort of the importance of this. You don't need to know how stuff works to fix it, funnily enough. You just want to get something that works and compare the differences. So we know now, with power applied to this one, we shouldn't get any voltage. We should get 3 volts on this pin and nothing on those two. Ground, and that should be 3 volts, and it's 1.4, so something's wrong there. This should be nothing, and it's 0.7. That should be ground, and it's got the 0.7. So this whole area here, to me, is definitely broke. So what I might do at this point to eliminate that, and the fact that we've tracked it down to there and found an issue, is I might just go ahead and remove this connector and see if that helps. And also we've got a fuse there we might as well quickly test. I'm pretty sure it's a fuse again, it says F2, so I'm guessing this is a fuse. So let's just do a quick check on that as well. So that one's intact, so that might be for this one, but that one was definitely blown and now it's working. So I'm just going to remove, I think, this DC connector. So now that's off, we can see the state of that in the first place. That's pretty corroded. So if I was going to use this anyway and fix it, if you will, I'd replace this. We can sort of see what's underneath, and really it's just, there's no reason why one of these pins would have voltage but the other not, because it's just a physical connector. So if I just clean that up a little bit again. We obviously don't want to leave the join on when I've desoldered it, because that'll just cause issues again. So that's clean enough for now. Let's just see if that's made any difference first. Get the testers and go straight in for a continuity test and see if the ground's now correctly connected to ground, which is not. So if this is connected and it's physically connected there, and then it's stopped there, and then the rest of the board, if you took it from the side that's disconnected, is sort of connected everywhere else that's a ground. You know, everywhere that should be ground works after this point. There's a clear disconnect between here and here. I'm just going to bridge these two directly together, because what I've got a feeling is the switch we've removed, you'd expect usually the shields to be the ground, but as we've proved with testing, the shield here, this input here going into 1 and 4 is power. So that's just a time when the shield isn't always ground. But these two pins are, the back two pins are definitely ground. And if we get the working one, then ground is on this side, and it's also on this side, and then obviously the ground goes out to the rest of the board. So what I'd bet is if we were to remove this switch, these two pins should be connected, and that's usually how they work. So let's just test the one we removed first to see if that's the case. I mean, in theory it shouldn't be, because they're not joined on this board. No, they're not connected. So my suspicion is these should be connected. And looking again at the state of the switch, it's probably just yet another component on the board that's broken down. But basically this pin and this pin, I'm sure, should be connected, and they are on the working board. So I've got a suspicion that maybe this switch is bridging the ground between this side of the board and then effectively the rest of the board. So let me just literally tack these two together for now. Now we will obviously have a join between them, but let's see if the rest of the board has now got ground, if that was just the only place it's kind of disconnected. So that's obviously joined now because I've shorted it. So that's got ground now. That's got ground. Does the switch now have ground? Right, so that's looking a lot better. So let's just power up again and see what happens now. Connect that power, connect that power. Oh, and we've got a light now, so that's a good sign. Obviously the switch won't turn that on and off because we've got that. So let's just take a look at the power draw. And you can see we've got 40 milliamps there, which is exactly the same as we had on the working board. Let me just get cutters and trim this down. Or in fact, I can probably just wiggle it off now. Again, love to be lazy. So we've got that in, the DC jack's off. The switch is hardwired. But let's just put this back together and see if the screen works and everything else works. Don't care about really any of all that lot. Just get rid of all the extra stuff. Place that in there. So let's just put the back on this now. And batteries. Ooh, that's a nice screen. show. Fixed in one way. Okay, let's try. This is the beauty of having a working board again. So let's just jump to the working screen and see if that works. And then we'll still use the old back and everything else. We're just purely swapping the screen. And that's stable. Right, let me just get a game and check this does work. So let's just put my Ever Game Boy drive in that lets me just dump all my original games onto this and play them all without having to change the disc. Let's see if this boots. Yep, so I've got my Pokemon games on there. Buttons work. So again, I'd do a full test, but this is with the original, with the working front end anyway, but with the backboard. So the physical, you know, these pads are the new ones, but they're easy to fix if there's an issue. So let's try and there we go. Just have to press it firm. This should reboot now with a game. Trading card games. That was the last thing loaded in. So yeah, it's working. Speaker obviously we ripped out, so that hasn't got sound. But overall, this is looking like it's now working for the most part. Let's take them out. So now the only thing left really is the screen is faulty. So we take a look at the screen. We noticed before it's got like a bit of a wear there. It's almost like that pin is potentially joining between the two. We could try and clean that off a bit there. There's a little bit of sticky, so that could be causing that a little bit of flicker. And then we could put a bit more IPA on. But again, I'm not too worried. That feels quite solid and potentially like solder, so this may well fix that flicker. But I'm not overly worried about this because I'm going to replace the screen anyway with a backlit one. Beyond cleaning this ribbon on the LCD, the only other thing left would be to take this up here and warm it up with a soldering iron, because under the sponge there is effectively soldered down pins straight to the LCD panel. So if this didn't work doing these pins, we'd potentially look at warming up the pins there. But I'm not going to bother doing that. So let's just see if that little fix on there has solved the screen issue. And then if not, like I say, I'm not going to waste time on that because I'm going to swap the screen, but that's all I'd do different. I'd just try cleaning this ribbon. And luckily that looks like it's fixed the screen as well. So let's just pop in the game cartridge. And yeah, can't press any buttons, stuff tipped them all out, but we've got no screen flick, so that's the screen fixed as well. So that's basically how I fix hardware. I've got no knowledge of the Game Boy Color, how it works, where the pinouts are, no schematics. I haven't Googled anything, I haven't researched anything. I basically just opened up the console, looked at it, cleaned what looks broken, done some basic testing to see continuity, voltages, resistance, really basic things. Nothing related specific to this. And we've identified many issues. We've got the screen that was broke, the fuse that was broke, the DC input that wasn't joining ground, the speakers that were broke. So we fixed a lot of things there. To be honest, that most people that have a lot of hardware knowledge would have struggled to diagnose and fix. And the point is, we've done this with very little knowledge. I'm kind of trying to show that to solve problems, you don't necessarily need knowledge. You simply need cause and effect. You need to look at something that works ideally and compare the differences. And then by process of elimination, just remove things, replace things, join things to get the same behavior. And it's the same way you do it in software. It's all cause and effect is the best way of learning. And as always, if you have any comments or questions or suggestions or anything you want to say or ask, leave them in the comments and I'll get back to all of them. And I hope you've enjoyed this one.